In the heart of Sydney, a city known for its opera house and dazzling harbour bridge, a quiet revolution was unfolding. The year was 2043, a time when the world was preoccupied with debates over climate change and pollution. Discussions often led to plastic waste, the invisible enemy that had turned oceans into a graveyard. The plastic land in the Pacific was just one of many. At the University of Sydney, a team of dedicated scientists had set out to answer this very question. Led by Dr. Lisa McDowell, a renowned microbiologist and geneticist, the team manipulated the genome of a peculiar strain of bacteria, Pseudomonas putida, using CRISPR, a revolutionary gene editing tool. The complex process at the lab involved engineering Pseudomonas putida to consume plastic more efficiently, turning waste into raw energy. By 2044, the plastic-eating bacteria, now called Pseudomonas sydneiensis, was ready for field trials. The first results were astonishing. The bacteria consumed plastic waste voraciously, breaking down the long chains of polymers into smaller, simpler molecules. The enzymes produced by the bacteria would attack the polymer chains, breaking them down into monomers, which the bacteria could then metabolize. Not only was the plastic waste being eradicated, but the metabolic process was also generating electricity, an unexpected but welcome byproduct. In 2053, the world looked like a utopia. The plastic waste that had once choked oceans and landfills was now being turned into raw energy. Sydney's transformation was nothing short of miraculous. From the Great Barrier Reef to the once litter-strewn streets of Sydney, the impact of Pseudomonas sydneiensis was clear. As Australia led the way, other countries followed. Pseudomonas sydneiensis was hailed as the solution to the world's plastic problem and energy crisis. The bacteria had not only given humanity a way to deal with plastic waste, but also a sustainable way to generate electricity. The possibilities seemed endless. As the years passed, the world began to experience the unintended consequences of Pseudomonas sydneiensis. The bacteria had done its job too well. Its rapid digestion of plastic and its infectious nature, spreading through microplastics, leading to an invisible pandemic. It spread like wildfire through people, animals, and even objects. The bacteria spread quickly and widely through ingestion of contaminated food and water. It wasn't harmful to humans, but it was the beginning of a crisis that science was struggling to solve. The life of Dr. Lisa McDowell was turned upside down. As the creator of Pseudomonas sydneiensis, she was blamed for the crisis. She found herself in the middle of lawsuits and vilification. Despite the chaos, she was eventually exonerated as the court recognized the bacteria's vital role in solving the energy crisis and mitigating the plastics problem. In the mid-2060s, a new evolution of Pseudomonas sydneiensis emerged. The once benign bacteria had mutated to become an aggressive eater of all things plastic, including the vital components of electronic devices. The collapse of digital civilization was gradual but inexorable. Vehicles stopped working, sewage systems collapsed, buildings with plastic infrastructures began to crumble, and every object with a trace of plastic began to disappear. Historically, such breakdowns have led to widespread panic, chaos, and conflict. As the digital infrastructure collapsed, so did economies, and countries began to turn against each other. The world came to the brink of war. Life became increasingly difficult for Dr. McDowell and her family. With each passing day, they had to rely more and more on items and technology that predated the plastic age. Her once high-tech laboratory was now a rustic facility. But Dr. McDowell was not done fighting. She knew that bacteria are predators and prey in their own microscopic world. They produce substances to kill each other, compete for resources, and form alliances. She also knew that using CRISPR to engineer another bacterium to fight Pseudomonas sydneiensis would be a monumental task. Selecting a suitable candidate, identifying the exact genetic sequence to edit, and the actual editing process were all major challenges. But she also knew that the survival of civilization depended on it. And so she began her walk, hoping to create a predator for the monster she had inadvertently unleashed upon the world.